Hi everyone, today we are going to be solving the two-sum problem. This is a very famous problem in LeetCode. So coming to the problem, you will be given an array of integers and a target value. What you need to do is return the indices of two numbers such that they add up to target. That is, array of I plus array of j equals target. Okay. And they also said that there will be exactly one solution. So we need not consider the case where there is no solution. So this is the question. There are many approaches to solving this, but first one, brute force. Now, in this, what we will be doing is checking each element with the other elements to see if they sum up to target. That is, let me just take this example. Instead of a 7, I'm going to be taking 8 and 7 at the last. You would be knowing why. So, you would be what you would be doing is checking if the sum of this number 2 with any other number is equal to 9 or not. And if it is, you would be returning these two indices. If it is not, and you exhausted this list, what you would be doing, you would be moving forward and then checking with this. So let me just show you that like this. Okay, first you would be checking 2 with 8. If this is equal to target or not, this is 10, this is not equal. So you would be checking 2 with 11. This is 13, this is not equal to target. Then you would be checking 2 with 7. This is equal to target, so what you would be doing is returning the indices. But let's just assume that we did not find our answer here. So what would you be doing? You would be going further because you exhausted this list, this one for the 2. So we'd be moving forward and checking 8 with other elements. 8 plus 11 is 19. This is not our answer. So 8 plus 7. This is also not our answer as that is 15. So now what you would be doing is choosing 11 and 7. This also doesn't sum up to 9. So this is the brute force solution. What you would be doing is having two for loops where I is from 0 to n minus 1, and then you will be having another for loop in this where j equals I plus 1 to n, and then you would be checking in this if array of I equal plus array of j equals target or not. If it is, we return. If not, we continue forward. And this is a brute force solution, and as you see, there are two for loops nested in each other. So the time complexity is O of n square, while as the space is O of 1 because we are not using any space. So this is the first solution, that is brute force solution. Now the next solution is the most optimum one. So yeah, could you do this in O of n? Because in the previous one we had O of n square. This is exponential. So when you have small input, this works fine. But when the array size is increased drastically, the time that is needed to compute this also increases drastically. So O of n is the linear solution. This, even though the size of the array increases, our solution can also be scaled linearly. So could you do this in O of n? Yes, you could do this in O of n. So let me just show you how. So let me just take the example again. Uh, Instead of a 7, I will be taking this as 8 and the 7 at the end. And our target is 9. So what you could do is, because we have O of n, right, our time complexity. Because our time complexity is O of n, that is linear, you can have one for loop. So in this for loop, what you would be doing is going from I equals to 0 equal to I equals 10, and you would be checking if this value minus this value, have you encountered this, the target minus the element previously. And how would you know the previous, I mean, if you have traversed that or not? You would be using hash map. So what would you be using the hash map to? Store the element and its index. So I would be, let's go to the for loop. First I would be at 2 and I would be checking if 9 minus 2 is present in my hash map or not. So 9 minus 2 is 7. It is not present in my hash map. So what would I be doing? Adding 2 to my hash map, along with it index. Now, next I would be going to 8. I would be seeing if 9 minus 8 is in my hash map or not. It is not there. So I would be adding 8 along with its index. Then I would be going to 11. I would be checking if 9 minus 11 is in my hash map or not. It is not there. So I would be adding 11 to my hash map along with its index. Similarly for 15. 9 minus 15 is not there in my hash map, so I would be adding 15 along with its index. Now I am at 7. And 9 minus 7 is 2. I would be checking if this is in my hash map. It is present. So what would I be doing? Returning the index of this 7 in the index that is stored along with 2. That is 0, comma. How much is this? 5. This is my answer. Okay. So because we have only one for loop, as I already mentioned, the time complexity is low of n. But because you are using a hash map to store the values, we have a space complexity of O of n. Because in the worst case, we have to add all these elements in our hash map, and at the end only we will be getting. This is the worst case. So that's why we have a space complexity of O of n and a time complexity of O of n. So this is for the explanation part. Now let's get into the code part. So as I said, we would be using a hash map or a map in C++. I will be naming this map, and I would have a for loop int I equals 0 to I less than nums dot size I plus plus. Now for every element, I would be checking if mp dot count what target minus nums of I, if this exists or not. If this exists, I will be returning I comma the indices of that. If this doesn't exist, what I would be doing is I would be adding that element's index to the hash map, and this is a base case which would not be executed anytime because they already said that there is exactly one solution, but we can't have a no return, so that's why we do put this, but this won't come up anytime. So that accepted. Let's just submit this. So as you can see, this is the most optimal time complex solution for this. But space, it isn't the most optimal one because it takes O of n.